tiny molecules that we can't see.
Each of those molecules are moving.
We call this movement
Thermal energy.
When we add heat, those molecules start to move around and bounce off of each other. They turn from a solid to a liquid to a gas.
So when we think of thermal energy, we think of moving molecules.
We have two containers, one with hot water and one with cold water.
Which has more thermal energy? If we place a bottle in each container and add a balloon on the top, we can make a very cool observation.
What's happening?
Notice how this balloon has not expanded at all. But as we add thermal energy, the air molecules in this balloon begin to expand.
In the case of the cold water, we have less thermal energy, so we see less expansion. Ooh, boy, that's cold.
I'm here today with Mr. B.
Hello.
I have placed in front of you several materials. Metal pan, a piece of cardboard, a piece of wood, and some foam insulation.
Please place them in order from coldest to warmest.
Okay, coldest. So can I put coldest over here?
Yep, sure.
The warmest. That actually feels kind of cold. I think I got her.
Would you be surprised if I told you they're all the exact same temperature?
I would be surprised.
So then, why does this feel warm and this feels cold? Thermal energy. Remember, molecules are always moving. Heat is how we transfer energy. As soon as you touch metal, your heat goes into it and it goes away.
Now, foam is a poor conductor.
In fact, it makes an excellent insulator. Look here, I have placed an ice cube on both a metal tray and a foam tray. The ice cube in the metal tray is almost gone, but the cube on the foam tray is still hanging in there. This is why we cook using metal pans. The more energy something has, the more the molecules move. If we add the heat, the molecules move even faster.
Convection, the movement of air, happens all around us from the heating and cooling of our house to cooking.
You can observe convection in a steaming cup of hot tea.
The steam is showing the heat being transferred into the air.
We can do a simple experiment in order to visualize this movement of air.
For our experiment, we will use smoke.
You will notice as the candle burns, the air surrounding the candle gains. As the candle burns, the air surrounding the candle gains thermal energy and it expands, making the air less dense than the air in the rest of the box.
This creates a buoyant force.
The hotter air rises and leaves out the glass chimney.
Cooler air enters from the other chimney and creates a convection current.
In this picture, I have cold water, and in this picture, I have warm water. I have a simple demonstration to show how the two interact. I'm supposed to record it slow. Notice how the warm water has made its way to the top. This movement is called convection. Cold water is denser. Its molecules are closer together, so the cold water settles to the bottom. Sweet!
The water looks like meat.
metal makes for a good conductor of heat.
Well, water is also a great conductor of heat.
Watch what happens when I hold a balloon filled with air over a candle.
Now watch what happens when he holds a balloon filled with water over a candle.
Why isn't it popping?
It's not popping because water is a great conductor of heat.
The heat energy is being distributed throughout the water.
By the way, this black stuff at the bottom is carbon.
Wow, that's cool. How does it work?
Well, the flame is trying to heat up the water in the tube.
Thermal energy.
The copper conducts that heat into the water. The water expands and tries to evaporate, creating steam.
Oh, the steam is forced out, propelling the boat forward.
Yup. And it will keep going because a vacuum is created, pulling fresh water back into the copper tube.
Very cool. It's a simple steam engine.
Yep.
Muldoon uses the radiation from his lamp to heat his body.